All right, hello once again, Jeff Scott of Rankin Technical College. We've been talking databases. I'm back in the textbook SQL A Beginner's Guide, 3rd edition by Opal, and we're in the middle of Chapter 7. So, we've been talking about the select statement, and I've shown you the from clause, the where clause. I'll go more into the grouping, group by, and having in just a minute. All right, and those are, again, different clauses that can be used in the table expression. As mentioned here, each clause within the table expression is evaluated in the order that's listed in the syntax. The result of running a query is what's called a virtual table. Virtual meaning it's really not existent. If you want to save the results of a query, you have to create a view, which we talked about in an earlier chapter, and I'm not going to go over right now. So again, the clauses in the select statement, as mentioned here on the middle of page 147, are applied in this order. First, the from clause, then, if there is one, the where clause, then, if there is one, the group by clause, then, if there is one, the having clause, all right, then the select, and then the order by. Now, this will become even more important when we get into chapters 11 and 12, and we talk about more advanced queries. All right, so let's just take it from the top, the select clause and the from clause. Again, select and from are the two required clauses in a select statement. The select clause, as I already showed you, includes the optional distinct and all keywords. If you use distinct, as you already saw, it will eliminate duplicate rows. But that's only rows that have duplicate values. So if I had said, for example, if I'd have gone to the employees table and I said select distinct last name, I'd still get 10 last names because they're all different. All right? The all, again, is the default. You don't need to use it. Whether you use all or leave it off, it returns all rows in the query result. All right? I've got a hard copy of this that I'm going along with, so if you see me or hear me moving this stuff, that's why. So you can use the distinct keyword to ensure that the query returns, for example, whatever it is, that everything that's in there is unique. Now, I mentioned this to you before. The author says, you state that you use an asterisk to include all columns in the query result. Does this ever present a problem? Well, technically, no, but it can present a problem, as it says here, if you've got a lot of fields and you really don't need all of them. So if you've got a lot of fields and you really don't need all of them, you should only put the fields in that you need in the select statement. If you do need everything, you use the asterisk. Otherwise, you use just the field names you need. Now, they give some examples here. I'm not going to run through these right now because using average, etc., those are aggregate functions that we go over in a later chapter. So I'm not going to talk about that. All right? Just going to jump down. The author gives an example in the database that they use in the book here. Select star from performers. This is the bottom of page 149 and the top of page 150. And then they say that if you do that, you get back all of that information. It's going to actually look pretty much like this if you do that. All right? Now, if you don't, if I have only 3 fields, I can say select star, or I can use the names. Now, if I say select star, I get them in the order that they were placed in the database. If I select the field names out like I did here, then I can change that order. So notice in the next example, we'll have performer name first, followed by place of birth. All right? And we're not even using the ID. So if we only want some of the information, then we have to list out the columns that we're looking for. Again, as the author mentions, if you were to specify distinct here, you'd still receive the same number of rows. Why? Because every name is different and every place of birth is different. That's why, in this case, the distinct keyword makes no difference. There are no duplicative rows in this table. All right? I always find this interesting. If I come back here, okay, and I say this, select star from employees where zip equal 63304, and you see what I get back. All right. What if I'd fat fingered here and I said 630,444? Okay. And notice I get back the empty set. That does not mean I wrote a bad query. What that means is I put in a query for which there are no records that meet the criteria that I'm looking for. So if you ever run a query and you get back the empty set, that doesn't mean you necessarily wrote a bad query. The query is still syntactically correct, but you did not have any records that met the criteria you were searching for. So the author goes on a little bit about this here and mentions in the middle of page 152, the select clause and the from clause are fairly straightforward, at least at this level of coding. However, once we get into chapters 11 and 12, we'll be working with more complex types of things, and this can get more complex then. All right? Next, using the where clause. Again, as mentioned, the where clause is used to give you criteria to search for. So it's assuming that you don't want everything. So you're putting in a search condition. And with that search condition, the author mentions here, the search condition is made up of one or more predicates that are used to test the contents returned from the from clause or by the from clause. A predicate is an SQL expression that defines a fact about any row. So here, in this example, we don't want every CD, copyright, in stock from this table. We only want the ones where the copyright date is between 1990 and 1999. Since it says greater than 1989, it must be 1990 or above. Since it says less than 2000, it must be 1999 or less. So this expression here means show me just the CD title, copyright, and in stock from the compact disc inventory table where the copyright year is between 1990 and 1999. Every predicate, as mentioned down here toward the bottom of page 153, every predicate evaluates to true, false, or unknown. If more than one predicate is used, you can return them together by using an and or an or. Let's very quickly look at that, but again, we'll look at this in more depth and breadth of coverage later on. All right, so what if I did this again? If I said select star where the zip is here, you can see those are the three. But if I say select this and department number equal 5, the only one I should get back here is Colin, because Colin is the only one that meets that criteria. But on the other hand, if I say where that's the zip code, or notice now I get back everybody with a zip code of 63304, but I also get back Ivy because Ivy had a department number of 5. So with an and, when you use an and like this, both criteria must be true. If I use an or, either one or both must be true. Ultimately, the author mentions here, and let me clean this up, I apologize. The author says, ultimately, the where clause as a whole must evaluate to true in order for a row to be included in the results. And they give you a couple of examples here of the or and of the and, but that's what I just did for you. Okay? And you can have as many ors or as many ands as you want. The other thing that you can put in there is not, which is called the inverter. Not true means false, not false means true. If you have a lot of different things in there with an and, all right, then every one of them must be true. If you have a lot of different things in there with an or, only one must be true. You'll notice on the top of page 156 here, the author mentions that SQL includes 3 operators you can use if a search condition becomes too complicated. Is true, is false, or is unknown. And they give you an example. First name equal Joni and last name equal Mitchell is true. I don't use that very much. I think it's much better to just specify what you're looking for in the same way I've been showing it to you. All right, so there's examples on 156, 157, 158, and 159. They are no better, nor are they any worse than the examples that I've been showing you. I'm going to jump into, should have time here, the group by clause right now. I've got left in here the group by and the having, and then quickly the order by, which we've been touching on, and we've looked at several examples of already. So we should have time to do this and finish this here. So the next clause, as it says, is the group by, which has a function different from the where clause. The group by, as its name implies, is used to group together types of information in order to summarize related data. I'm going to do this. I gave you that group by before and it didn't work right, but I'm going to say this. Select count star from employees, and that should give me 10. Because it says, how many employees do I have in the database? I have 10. All right. I'm going to try this again, select count, and I'm going to say group by zip. All right. Now, you might say that doesn't show much. Well, let's do it one more time. Let's do it, instead of saying select count star, all right, let's say select zip, comma, count star from employees, group by zip. Oh, sorry. There is no zip. All right. Now it's showing us some information. It's showing us that we have 2 employees that work in that are from the 63303 area code, 3 employees from the 63304 area code, 2 employees from the 63367 area code, and 3 employees from the 63385 area code. Now, this wasn't a bad example per se, but I tend to use a lot of group by, all right, when I'm putting together department numbers or maybe salaries that fall or something like that. We're going to use group by even more when we get into talking about the aggregate functions. I could run this same kind of query. So instead of saying this, I'm going to say select department number, count star from employees, group by department number. All right. That says I have 2 employees that work in Department 1, 2 employees in Department 2, 2 in Department 3, 2 in Department 4, and 2 in Department 5. Now, by itself, you look at that and say, well, that doesn't show much. Again, as we go on and we write more and more complex queries, ideally, you'll see more and more why we might want to use that. There's also a roll-up and a cube that you can use here, and I believe the roll-up works. And the cube, I believe I had a hard time if I got it to work at all, and I don't think I got it to work in the with MySQL. Remember, this is a book on SQL, not a book on MySQL. All right, I wanted to show you there we go. So I'm going to run one more query for you here, the same one that I just ran, group by department number, and I'm going to say group by, and I'm going to put up here roll up, not fold up, department number, and it doesn't like it. And I remember going through this because I had done these examples earlier. So MySQL rollup. I think it's a syntactical thing the way that I put it in here. So let's see. Oops. So it's group by that with rollup. Okay. So that was on me. Group. So I want to say group by department number, as we had, with rollup. All right. What the rollup does is it adds everything together that you asked it to add. Okay? 2, 4, 6, 8, 10. So it's null here because there is no department number. This is just the total. All right, again, we'll look at some of this stuff in more depth and breadth of coverage as we go on. Now, what I did not mention to you before is mentioned in the textbook here that we're looking at online on the bottom of page 164, starting there. And that is talking about the having clause. All right? So using the having clause to specify search group conditions. And the author says the having clause is similar to the where clause because it defines search criteria. But the having clause is concerned with groups, not rows. It gets confusing because, as you can see here, if you have a group by and a having, then the having is applied to the groups created by the group by. If you have a where and no group by, the having clause is applied to the output of the where clause. If there's no where and there's no group by, the having is applied to the output of the from clause, which this is, I think at least, a little bit, for lack of better words, a little bit hard when you first start looking at it. So let's do this. All right. Let's run the same thing without the roll-up, but let's run this. We'll forget about the roll-up. All right. But I want to say this. Having department number equal 3. Okay? So instead of showing me everything, it only showed me a count of how many people were working in department 3. So again, like we saw before, the having works with adding additional criteria. And there are other ways that this can be used. Again, when we get into talking about the aggregate functions in later chapters, we will look at this in much more depth and breadth of coverage. And the last thing that's in here is the order by, which we've looked at. When you say order by price, for example, you get price. It's in ascending order based on price. Now, what order are these in? Well, if you only say price, then you have no control over the order other than that they will be in ascending order by price. If you put order by price DESC, it'll give you it in descending order based on price. So the order by clause, if you use it, must be the last clause. It takes the output from the select and it orders the query results based on what you put in the order by. And that pretty much finishes up the chapter. Again, the author has examples of the database that they use in here. I've decided not to use their examples. So I'm pretty much done with Chapter 7, which gets us to around page 176 or so. In the next chapter, we'll come in and start talking about modifying data. We looked at the select where you can't change the data. In the next one, we'll look at modify, which are insert, update, and delete. Now, I want to just leave you with this very quickly. All right? What we talked about in this chapter is we talked about the select statement. In the next chapter, we'll talk about update, insert, and delete. And what I want you to realize is collectively, select, update, insert, and delete, collectively, these are referred to as data manipulation language, or DML statements. All right, so these are our 4 different DML statements. And I separated select from update, insert, and delete because select cannot change the data. Update, insert, and delete do change the data. So as we go on, we're going to be working more and more with this stuff. We've already done a little bit of looking at, not much, but a little bit of looking at the data definition language, or DDL statements. And those are create, alter, and drop. So those are our statements that we have. Let me cut down the size of this just a little bit. So those are our 4 DML statements, which we're concentrating on in this section. We've already looked a little bit at the 3 data definition language, or DDL statements. So I'll be back shortly to start going over Chapter 8.